Let's look at some examples, like 38 on page 92.
Yes, sir.
Now this is pretty doggone simple. You guys have probably been solving linear equations like this since early high school, late middle school, when you first encountered an x and so forth. And you got a basic strategy. You get your x's on one side, you get your numbers on the other, right? Divide both sides by the coefficient of x, you finish. Basically works that way. But there's some principles that we need to keep in mind, lest we make some fundamental mistakes with solving an equation. The one concept you need to keep in mind is that equal sign right there. That tells you that an equation is a balanced scale. That's basically what you got. The equal sign says the weight on this side is the same as the weight on this side. And you know how physically a scale works. If it's balanced, whatever you do to one side, you got to do the other, right, to keep it balanced. If you put 5 pounds over here, you got to put 5 pounds over here to keep the thing balanced, right? If you take half of this off, you got to take half of this off to keep the thing balanced, right? So whatever you do to one side, you do to the other to keep it a balanced equation. So we're going to keep that in mind. And you're basically going to pick a side for your x's, pick a side for your numbers. In this instance, which side would be most logical to put your x's on?
The left.
Left side. That keeps them positive. Nothing wrong with putting the x's on the right side. You'll have some negative x's, and most people try to avoid that, but no big deal. So that means I got to add 2x to both sides, right? Because the way you undo a minus 2x is to do the opposite, add 2x. Those are opposites. They go to 0 by definition. That's 7x. And the same thing with the 3. It's on the wrong side. It's on the x side. I need to get rid of it. So the way you get rid of a plus 3 is to
Subtract it.
from both sides. Now we've accomplished our first goal, to get x's on one side and numbers on the other. Now what do you do? Divide by the coefficient of x, which happens to be 7. And you're correct. This reminds us, by the way, that we shouldn't be always looking for a neat whole number answer. Life doesn't come out even, so these problems don't come out even. So expect fractions, negative numbers, decimals, whatever you got. Don't worry about that. Yes, ma'am.
I got a negative 3 over 7.
Okay, let me ask you a question. What did you divide both sides by?
I brought the,
What'd you do?
okay, I brought the negative 5 to the other side.
Okay. You brought this to the other side.
Yes.
And by the way, do y'all know the shortcut that I'm sure most of you use anyway, and that is, if I move a term to the other side, what do?
Change the sign.
Change its sign. You don't make it negative, because it might start out negative. You change its sign. All right? So I move the 5x over here to give it this x. I make it minus 5x.
So on that side it became negative 7x, and then I brought the 6 over to the 3, and it became negative 3.
Very good.
So I got negative 3 over negative 7 equals 5.
Okay, now look at your,
Oh, yeah.
what'd you do? What do you need to do?
The negative 7 over.
Yeah, you need to divide both sides by whatever's in front of x. Yeah. You get the same thing. And thank you for doing that. Because that reminds us that if I chose the other side for my x's,
So you just changed the positive.
absolutely. Negative over negative, even number of negatives, positive. Yep. So if you put the x's on the right and the numbers on the left, you're going to get the same thing. But that's the shortcut, you know. If you move a term to the other side, you change its sign. That's what most of you do anyway, instead of saying plus 2x plus 2x. And a lot of you do it mentally. All right, let's try another one. Let's try 42. Oops, that's a mouse. Sorry. Hey, what you gotta do first? A
Distribute.
little distributive, yeah. Let's do that. That's 4x. That's minus 10. Hey, what you gonna do next? You got some terms to combine, do you understand? You don't have to do that next, but that seems to be logical. Okay, here's where you might say, let's get the x's on the other side. So I'll move this guy over here, get the numbers on the right side, move that over here. So I get 9x minus 9x equals negative 10 plus 10. I get 0 equals... Where'd my x's go? They went to math heaven, ladies and gentlemen. They're gone. Hey, how would you describe that statement right there?
Redundant.
True. It's true. 0 is equal to 0. In fact, this is a universally true statement. And whenever I get a universally true statement, notice no x's. No x's. Whenever I get a no x statement that's universally true, that says 0 equals 0 in this case, what's my conclusion about the solution? No solution. I'm sorry, what? All real numbers. That's it. If I get a universally true statement, I am so ecstatically happy that I allow all real numbers to be in the solution set. All right? So the solution is all real numbers. You know what that means? That means if you put in that original statement any value in there for x, I mean any value in there for x, negative 75, pi over 14, 3.117894 in there for x, you're going to get a true statement. This guy is called, if I get a x-less statement that's completely true, 5 equals 5, 0 equals 0, okay? If I get a statement that is universally true, this guy is called an identity. And identities are true for every single x you put in there. With these two examples, ladies and gentlemen, you have seen two things that can happen when I solve an equation. The most common thing that happens is I get an answer. X is 3/7. X is 4. X is negative 2. X is something, all right? That's called a conditional equation. It's true under the condition that x is 3/7. This is a conditional equation. Why? Because it's true under one condition, that x is 3/7. This guy, on the other hand, is true no matter what x is.